Welcome to everyone. Previous class we have discussed about a matrix. Today class we will discuss about the representations of groups. Representation of group. So we can represent the group in two ways. The one way is reducible representations. One is reducible representations of group. Reducible representations of group. Another way is irreducible. This is the first way. And second way is irreducible representations. Irreducible representations. Okay, so we'll discuss one by one. Today class basically will discuss only this reducible representations. In tomorrow class we will discuss about irreducible representations. Okay, let's start. Before I start these chapters, previous class I forgot to mention that characters of identity elements represents the dimensions of the group. But it means that if the characters of identity elements is 1, then it says that group is 1 dimensions. And if the characters of that identity elements is 2, then group is 2 dimensions. Similarly, if identity this is 3, then group is 3 dimensions. And if the identity element is 4, then group is with 4 dimensions. So that characters of identity element says that what is the dimensions of the group. Okay, so see that 2 dimensions means 1 0 0 1. This is the 2 dimensions. 3 dimensions means 0 0 0 1 0 0 1. This is the 3 dimensions, like that. Okay, so 1 dimensions means only 1 is there, and for 2 dimensions this 3 dimensions, this 4 dimensions, 4 will be there, like that. Okay, and we know that this is the one type of unity matrix where mainly we will know that 3 into 3 is there, means both the elements will same. Here 3 means here also 3. Okay, so this is the 3 dimensions, and we are basically in matrices in group theory we will discuss about of the unity matrices. Okay, so these things yesterday previous class I supposed to say, but I forgot. Sorry for that. So next we will start with the reducible representations of group. So we will discuss reducible representations. Reducible representations of group. So reducible representations of group, here what we will going to discuss. Sorry. So in this reducible representations of groups, that we can derive the reducible representations on the basis of 3 ways. So derive the reducible representations on the basis of basis of mainly three ways. What are that? First is on the basis of x, y, z axis, and second way we can derive on the basis of 3n systems, 3n coordinate systems. I can write 3n coordinate systems. And other third way is on the basis of bond vectors. So we will discuss one by one. First we will go with on the basis of x, y, z axis. So if we discuss on the basis of x, y, z axis, what is said that let's say if any water molecules, this is water molecules, you can take any examples. Let's first we take water molecules and we can take other examples. That's water molecules. Here that point group is C2B, and what are the elements are there? Symmetry elements or symmetry of variations. So one is we have that C2 axis. So if I say that this is x axis and this is y axis and this is z axis. So let's fix that. We always take this x, this is y, this is z. If we change the axis, then our answer also going to change. So it is better to fix the axis. So we will fix this x, this is y, and this is z axis. So if we fix this axis, then if I do that C2y axis, then what will happen? This will get interchanged. So this water, let's say this is H1, this is H2, then this will go here H2, this will go H1. Okay, so this will get interchanged. So here C2y axis is there. With that, first is E is there, E for every group, and then C2y. After that, we have that plane passing through oxygens, and it will reflect H1 and H2. Again this will get reflected. So we already discussed that this is passing through y and z axis. So this is sigma y z axis. Sigma y z is also there. With that, another planes which is cutting all the atoms, molecular plane, that is x and y, means this water is in the like planar, then xy which is the planar, that is sigma xy. This is also there, sigma xy. Okay, so these are the symmetry elements present in this C2B point groups. Okay, so now what we will do, so let's say if E is there, then if I write x, y, z, so if I write x, y, x1, y1 and z1, so due to E nothing will change. So due to E nothing will change. So this will be 1, 1, 1, and so we can say that E, C2y and sigma z. So you are discussing on the basis of x's, right? So if I say I can write that C to B, these are the symmetry elements of the point group C to B. Then if I write, okay, so we can do like that. We can say effect of excess. So if E is there, then where the effects will happen. Let's say that that we can do here, effect of excess. This is not so important, just for this. After that we take other way also, just we will take one way. So if that let's say if we are applying x-axis, and if x-axis, due to x-axis, if any change happens to E, then we will write 1, we will write -1 if changes happen, if changes happen, if changes. And if x-axis no change, applying this E, then we will write 1, no changes, like that. Then that E, due to E x y z axis, any change will happen? No. So we will write effect of here, I will write x, y and z. So due to E any change to x? No. So 1. Due to E any changes to y? No. 1. Z no changes, because E is, that is nothing operations. Okay, after that let's say C to y. So this will be unchanged. After that these two will change. So this is -1, this is 1, this is -1, and sigma yz only this will not change, this will change. So -1, this is 1, this is 1, and for xy this will not change. So this is 1, this is 1, and this is -1. So what you do after that, we do sum, we will do the summation, we will do the summation. And what you will get, this is 3, this is -1, this is 1, this is 1. Okay, so this is the we can check this way, that xyz, if you apply that E to xyz, then nothing will change. So every x power 1, y power 1, z power 1. And if you pour C to y, then that this is axis, only that y will remain unchanged and this will change. So -1, 1, -1, like that. Okay, so this way, or this is the same as, we can say that this also we can say here, that x-axis here, that 1 represent no change, no means 1 represent unchanged, and minus represent changes, change. Okay, so this is the other one way. And the other way also you can say that if C to B point group is there, that is E. Now I will do here itself. This one also I can say that C to B point groups, here E plus C to Y plus sigma yz and plus sigma xy. So we know that characters of E is 3, that we have discussed previous class, and C to Y is always -1, C to Y. Okay, we know that the character of C to Y is -1, and this is always 1, 1. Okay, so this, okay, so this one and this one we can also do by this way, also we can do this way, because we know the characters of E is 3, and for C2 is -1, and sigma always is 1. Okay, so that we have discussed, or we can do by this way. And if it is not compatible to you, then we can also do like that we know that character of E is always 3, and C2Y is -1 always, and sigma yz is 1, 1. So by taking the characters we directly do that. Okay, for C2Y, what, 2 cos theta plus 1, this is the formula. If not C2Y, if C3 and C4 is there, then use this formula and you get the characters. So whatever the character, you just put it. Okay, this way, or we can do by using XYZ, and if E, then no axis is changed, that's why this is 3 8. If that C2Y, then Y will not change, these are changing, that's why this -1 this is 1, like that also you can do. So this is the reducible representations. This is the reducible representations along on the basis of X, Y and Z axis. Okay, so I can do here. So I will do here C2 will be, that is C2, first is E plus C2Y plus sigma YZ plus sigma XY. So what I do that here, this is 3, this is came, this is -1, this is 1, this is 1. Okay, so this is the reducible representation, reducible representations on X, Y, Z basis. Okay, so this shows that reducible representation. This is the symbol of reducible representation. Reducible representations, and this is the shortcut for reducible representation. This is actually a reducible representation. Okay, so this is the on the basis of XY axis we can do that. On the basis of XYZ, either we can do, or we can directly put the characters of these values. Okay, so both way you can do it. This is the representations on the basis of X, Y, Z axis. Now that next way is on the basis of 3n coordinate systems. On the basis of 3n coordinate systems. Here what you say that 3n coordinate systems. Here n represents, this n represents the number of atoms present in the molecules. Present in the molecule. The number of atoms present in the molecules. So let's say for water molecules, if I talk about the water molecules, let's say for water molecules, how many atoms are there? So this is 1 2 3, 3 atoms are there, so n equal to 3, then 3n will be equal to 3 into 3, that is equal to 9. So 9 coordinate systems are there. 9 coordinate systems. So how can you represent this 9 coordinate systems? Let's say this is water, so we will represent that one axis here, another for here, another for here. So this is 3 3 6 3 9. Okay, so if I represent, this is x1, this is y1, this is z1, then this is x2, this is y2, this is z2, this is x3, this is y3, this is z3. Okay, so total is 9. This is 3 3 6 3 9. Total is 9 coordinate systems. Similarly, if you take about of ammonia, let's say ammonia, so here will be N H H H. So how many atoms? N equal to number of total atoms present in the molecules, 1 2 3 4. So 4, and this is 3n, that is 3 into 4, that is equal to 12 coordinate systems. That is I can represent this nitrogens, this nitrogens, hydrogens, hydrogens, hydrogens. So here the one coordinates will be there, here one coordinates will be there, here one coordinates, one coordinates. So here x1, y1, z1, then this is x2, y2, z2, and so this is x3, y3, z3, this is x4, y4, and z4. So this is 3, 3, 4, 6, 3, 9, 3, 12. So 12 coordinate systems are there, likewise. Okay, so let's derive that 3n coordinate systems for water. After that we will look for that NH3 also. So let's derive derivations of 3n coordinate systems for water. Okay, so how can we derive? Coordinate systems for water, if I want to derive it, then okay, so for water, so I have to derive like this: oxygen, hydrogens, hydrogen. Let's say this is H1, this is H2. So 9 coordinate systems are there because 3 into 3, that is equal to 9 coordinates. So 9 coordinates I have to draw. Okay, so here is one axis, here is another axis, here is another axis. Okay, so let's say this is x1, this is y1, then this is z1. Similarly, this is x2, this is y2, and this is z2. Similarly, this is x3, this is y3, and this is z3. Okay, so here I will apply that. So what are the symmetry elements? So C2B is the point group, and what are the things there? E is there, plus what things are there? If I draw here, then here if I pass that planes, let me pass with this. So this is C2Y because this is y axis. So if I pass this, then C2Y. Okay, so C2Y is there. With that, another is plane is there. These directions, plane is cutting through y and z. Yes. So sigma yz. Another is molecular, which is cutting all the atoms. Okay, this is sigma xy. So that is sigma xy. So you can see that this is the like if I search, this is the water molecules. Then on C2 axis is there, that is C2 axis is this directions. Okay, if I reflect 180 degree, then this will get interchanged, this will get or this way, this will, let's say y axis passing through these directions. If you do 180 degree rotations, then this will get interchanged, and like this it will become. Okay, so C2y is there, this is y axis, this is x axis, and this is z axis. So this is along y axis. C2y C2 I rotate. Another is, what are the planes? One plane is cutting that C2y, above one is C2y, another is z axis. So C2, this is z axis, this is y axis, and this is x axis. So cutting through coming, this is z and y. Okay, so C2 C sigma yz is there. Another is, this is y and this is x. So I am cutting xy through the whole molecules. Okay, so that is xy planes. Okay, so these are the planes we have. So we have to do these operations to these water molecules with these 9 coordinate systems. So let's do one by one. So if I do for E, so first I will do So the case 1, if I do for E, then what, that this is water molecules. So if I do the E, then nothing will change will happen, the same water, this is H1 H2, then same, this is H1 and this is H2, so nothing will happen. So in coordinate system also, if I apply E, I have to give the 9 coordinates. So this is x1 y1 and z1, x2 y2 z2, x3 y3 and z3, means this all coordinates I have to mention, x1 y1 z1, x2 y2 z2, x3 y3 z3. Okay, so that's why I mentioned all that. Okay, after that, what here x1 y1 and z1, here I will buy another pen. Here x1 y1 z1, here x2 y2 and z2, here x3 y3 and z3. Okay, so here that first I will apply x1 y1 z1, so here is there, so this is 1, x1 is there, 0 0 0 1 0 0 0 1. Okay, this is the unity identity. Okay, that is 1 1 1, diagonal is there, other is 0, that we have already discussed in the previous class. And here x1 is there, this is not there, this is here, so this will become 0 0 0 0 0. This is not here, here is there, so this is here only, here is not there because this is here, so this also getting 0 0. Okay, similarly this is here, not here, so this become 0 0 0 0 0 0 0 0 0. This is there, so that's why here 1 0 0 1 0 0 0 1. Okay, and here not there, this is here only, so this will become 0 0 0 0 0 0 0 0. Okay, so now this is not here, 0 0 0, this is also not here, so 0 0 0, this is here only. Okay, this value, so that's why I represent this, so this is here only, so whatever this value is present here, so here only this value will come, this value is not here, this value is not here, this value is only here, that's why here only value has come, this value is only here, then here only this value has come. Okay, so you may understanding that. Okay, so what are the characters? Characters mean, character is that characters of diagonals, so this is E operations, so all the diagonals I have to add, character means summation of the diagonals, so I have to add these values, all the diagonal values I have to add it. So 1 1 2 3 4 5 6 7 8 9, so this will become 9. Okay, so 1 we will apply, next with next characters we are having in water, 1 we have seen, next character is C2Y. Let's look now C2Y. Likewise we have to check all the symmetry operations. Now I will apply for C2Y. Okay, so if I apply C2Y to these matrices, then what will happen? See, this is the water molecules H1 and this is H2. So now I am applying that, here coordinates also there, this coordinates also there, this is x1 y1 and z1, this is x2 y2 and z2, this is x3 y3 z3. so here I am applying C2 along y axis. Okay, so here if I apply that C2y, then what will happen, So here if I see to apply, then what happen? This and this get interchanged. It means what is here? Here will go H2, here will go H1. Okay. And this oxygen is remain as it is, means here that coordinates will be different. Here the coordinates are different. Here the same coordinates will be here. Another things that this is the water molecules. Okay. I apply that C2Y along this directions. Along this direction, C2Y, this direction. So whenever I interchange it, then this is get interchanged like this. Okay, means this axis will go here and this axis will come here. Okay, whenever I apply it, this will get interchanged. It means that here will come to that. And one more thing is that, let's say this is the x-axis, sorry, this is y, this is x, and this is z-axis. Okay, front one is z-axis, this is y-axis, and this is x-axis. So whenever I rotate by 180 degree, then what will happen? See that this is in this sides, that means right side will go back 180 degree rotations along y-axis. This direction I am rotating. Okay, I am rotating along this from the front. From here I am rotating. Okay, this is in the front, this is in the right. So I will rotate 180 degree along these directions. Then what will happen? This will go here and this will come back. This will go, this blue one will go here, this direction, left direction. If I rotate 180 degree along this red. So this is, you see that, you see, so this has come to the left and this black one come to the back. This remain as it is. Okay, previously was this way. So whenever I rotate 180 degree, then this is the right, this will come to here, this sides, and this is in the front will come to the back. 180 degree rotations. Okay, it means that whenever I do 180 degree rotations, then what happened? That y-axis remain as it is. So first this H1 H2 this is interchanged. It means that here x3 comes and we may see that but this is get interchanged. First atoms has interchanged, and secondly what also there, that this whatever in the right side, this is x-axis, this is z-axis, this is y-axis. I'm rotating along y-axis, so this axis changes to this directions, means x-axis become negative. This directions, if I do 180 degree, then this side right go to the left. You see 180 degree rotations means what things happening, that here the atoms has changed. That the first things. With that, what is happened, that this directions x3 first, it is this H2 has come here and this x3 is go to this directions and y3 is remain as it is, and z3 which is in the front, that will go to the back. Means if I draw like this direction, this is the back of y, this is let's say x3, this is y3, this is z3. So this is get to this direction, this came. Now this x3 will go to this directions, minus x3, and z3 will go to here, minus z3, and y is remain as it is. Okay, because this directions, if I do 180 degree rotations in the in this direction, this is the x-axis and this is the z-axis. After 183 rotations along y-axis, what happened? They are getting, this is the right side, this will go to the left. You see, it's going left side, means it is changing. Okay, so this is become this, and y is as it is. This red will be same after rotation also, this is not changing. Okay, this is happen to this. Same case here also, the same things will happen. first atom size interchange. So here that this plane will go here, so y1, so let's say this is x1, this is z1. So after that 180 degree rotations, z1 is come here and x1 is go here. Okay, this will happen. Same things for this oxygen also, that this is the front, this will become back, this all getting back. Okay, so same things this here also, same things will happen, that this also, see that this is oxygen atom, let's say this is oxygen atom. After 180 degree rotation, this also getting back sides, means let's say this is the front side, 180 degree rotations, the back side is coming. Okay, so here also the same things will happen, but it will not change, means x2 y2 z2 is there, same things will stay, but just axis will change. This was there, here was x2, here was y2, here was z2. Now this x2 will go here and z2 will go here. Okay, so this is happened to this. Okay, so this hydrogens get exchanged and their axis also exchanged, and with that the axis directions also changes. Here only, here atom size not exchanged, but the axis direction size changes. Okay, so if you represent in the group, then how will you represent it? So C2Y. So previously I was writing x1 y1 z1, but now they get exchanged, this goes to here, this goes to here. So in place of x1 which has come, x3 has come, so I will write here x3. So I will write C2y, here I will write x3 y3 z3, and here the oxygen is not changed, so this is x2 y2, this is z2, and this is came to be x1, this is y1 z1. Okay, so in this first place x1 I will write other pen, let me write with other pen. Okay, here x1 y1 z1, here x2 y2 z2, here x3 y3 z3. So here x1 y1 is not there, so this is 0 0, because this one has to come here. So here x3 is there, so here is x1, so you will not write 0 0. Okay, and y2 also not there this position, so this is 0 0 0 0 0 0 0. So x3 is there, yes, so 1, and also that axis also get changes, but this is x3 become minus, so this is minus, and z3 also minus. Okay, only this is not changes, so it become -1 0 0 1 0 0 0 -1. Okay, similarly x2 here not there, so 0 0 0 0 0 0 0 0. x2 y2 z2 is there, yes, so this will be, and this is also same case, this x3 is get negative and this also negative, y is not negative. Okay, why? Because this is remain as it is, only these two are changing. Okay, 180 degree rotation, so this is -1 0 0 0 1 0 0 0 -1. Okay, here not there, so 0 0 0. Okay, so similarly this is there, and this is also, this is minus, this is minus, this is 1 0 0, this is 0 0 0 0 0 0 0 0. Okay, So if you operate all this, then so characters is the diagonals of C2 y is what? Here is everything is 0, so this is going to be 0. Here that this we have to add. Here also everything is 0. Here also everything is 0. Okay, so this is only that. Then -1 -2 plus 1, that is -1. So characters of C2y equal to -1. Okay, now next we will do sigma yz. We will do let me check if any video everything is getting good. Okay, so let's say this is the water molecules H1 and H2. We will apply that sigma yz. Sigma yz we will apply. Okay, so if I apply sigma yz is along this direction. This is x, this is y, and this is z directions, means I apply the plane like this. Okay, this is sigma yz. Let's say this is the water molecules, this is the water molecules. Yes, I am applying the plane this directions, cutting this middle of that water molecules, means this directions I am cutting the plane like this, means this will reflected to this and this reflected to this. Okay, so if I apply that sigma yz, then what will get? Oxygen here got H2, here get H1. With that 3 coordinates is there. With that 3 coordinates are there. Okay, so now here that x1, y1 and z1. Here watch x2, y2 and z2. Here is x3, y3 and z3. So after sigma yz, these two get exchanged, means this x1, y1, z1, this and x3, y3, z3 come to this. Okay, and that this x2, y2, z2 remain as it is, as here itself. Okay, so so after this rotations, what you get what we will get is, so you see that axis is like this. This is, let's say that y-axis, this is x-axis, and this is z-axis. Okay, now this is along x-axis, this is y-axis, and this is z-axis. Now if I pass the planes, this is along y and z. This is y, this is sorry, this is y, this is x, yes, this is x, this is y, and this is z. Okay, this is z, this is y, and this is x. So if I pass the planes along yz, means this is z, this is y. If I pass the plane along these directions, means cutting this and this. Okay, so cutting this red and black one, then this blue get reflected. If I pass the planes cutting this z-axis and y-axis, then this blue get reflected and this will come to this side. Yes, if I pass the planes cutting y and z-axis, this is z, this is y. If I cut the planes cutting this z, this red one and this blue one, so this black one, then this blue get reflected to this directions. It means what I said, first this will go to here, and since this is passing through y and z, so y and z will not change. So this is y will not change, this y is not change, and z is also not change, and this x will be go to x sides. Okay, this is about of x1, y1 and z1. Similarly here, what this h came here, this is y3 and z3 is not change, and this y1 is, so y3 is go to here back sides, so this has changed y3. Okay, because that plane is this directions, and this is z axis, and if this is y-axis, this is x-axis, this is z-axis, and this is y-axis, and the plane is passing through this red one, this is y, and this z black one. Then if plane is come like this, if plane is come like this, cutting this red one and black one, then this blue one get reflected to this back sides, this will reflected in the back sides. Yes, this will reflected after that to the back sides. Okay, that's why this is why previously this was this directions, after plane this become this sides, and since plane contain this and this black one, this will not change, only this will change. So this is y, sorry, this is y. Okay, so this is y, no, this is x. Okay, this is y, this is z for me. Okay, so this is this x will get to this directions. Okay, so this x3 will be this directions. We understand now, because so this is y and z, this contains the plane, and this x-axis is in directions, so due to reflection this go to back sides, so this x3 get this directions. Similarly here also same things will happen. So z3 sorry, here is no replacement atoms, oxygen remain in its own place, so this is again z2 and y2, and x2 will go to this directions. Okay, so if I draw the coordinates for this atoms, then I will write sigma yz, then x1 y1 z1 y2 z2 x3 y3 z3. Okay, so this is x1 y1 z1, this is x2 y2 z2, this is x3 y3 z3. So this was actually original, but now previously this was this way, but whenever I pass the plane, so this come to here and this goes to here, h2 come to here, h1 come to here, with that axis also interchange, so this go to here, so here comes x3 y3 z3, and x1 y1 come to here, this become x1 y1 and z1, because this h1 and h2 after applying plane this get interchanged, so with the axis, with atoms axis also interchange, that's why here h2 x3 h came in this direction, previously this was there, now after that, after plane this h2 come to here, okay, with that axis also come to here, so this one, so now here x1, so this is x3 y3 z3, so this is 0 0 0 0 0 0. Okay, here also x3 not x2 y2, so this again 0 0 0 0. Okay, now this x3 y3 and z3, one thing I says that this and this remain as it is, and x3 has changed, so this is become negative. Similarly here also this is negative, this is negative, so I will put -1 0 0 1 0 1. Okay, similarly here it's 1 0 0 1 0 0 0 1. Here not there. Oh sorry, this is about of x1 y1 z1, this is x2 y2 z2, so this is 0. So here x2 y2 z2, so here it will come -1 0 0 1 0 0 1 0, sorry 0 1. Okay, this is not there, so 0 1 0 0 0 0 0 0. So here it is there, so this is -1 0 0 0 0. Okay, so this is not there, so this is 0 0. Okay, so wherever here it is there, which case that is there, this there, that's why here value h came. Here this case, in this case here, that's why here value h came. Here in this case it is not there, so 0 0. In this case also this value not this one, so 0 0. In this case here, yes, same value, so here the value h came. Okay, so now if we now the characters of sigma yz will be all the diagonals, so add all the diagonals. Okay, so what is the value? 0 minus this is 1 1 minus 1, that is going to become 1. Okay, 2 minus 1 1, so this is the character, this second 0, so 1. Okay, so similarly way we can do for next one, that is sigma xy. So sigma xy if we do, then what to do? This is the water, this is h1 and this is h2 and this is x, this is y and this z. So now I am applying xy directions. Okay, so xy directions, it means cutting the all the atoms. This is the sigma xy, so apply this. Is there any change? So it will not change, but it will go the back sides. Okay, so if this is the atoms now, so the atoms will not change, but axis will change. Okay, so see, this is the z axis, this is y axis, this is x axis. Now the plane is this directions, plane is this directions, means cutting containing y and this is y and x axis. So which will get replaces? This z, this will get replaces, because this and these are contain the plane. So which are the contained plane, that will not get replaced, so this will reflected, which will replace this black one, that will go to the back sides, so that will go to the back sides. Okay, like that. Okay, so here this is the this direction, then this is direction, the plane contain the x and y, so this was this directions. After plane, this will come to the back sides. Okay, so here if we apply, then here the coordinates will be there, here the coordinates are there, here the coordinates are there. So the same one here, x1 y1 and z1, here x2, here y2, here z2, because they will not change, because this is same, this is not changing. Okay, so here was x1, here x1 y1 and z1, here x2 y2 z2, here x3 y3 z3. So same, that will not change because atom is not changing, but that these planes contain xy, so z is getting changing. Okay, because I explained that this is x, this is y, this is x, and this is x, this is y, this is z. So plane containing x and y, so which will get changed? this black one will change because this and this contain in the plane. Okay, so this black one will come to the back sides. This is like this directions, this will come to the back sides. So if you calculate it, then the characters, so this the characters how it look like, the sigma xy, then you look what of x1 y1 z1 x2 y2 z2 3 y3 z3. So xy, so only this z will be changing this because this is contained in the plane. This will negative, this will negative, and this will negative. So here x1 y1 z1 x2 y2 z2, here x3 3 z3. Okay, so here x1 y1 z1 is there. Okay, so this is become 1 0 0 1 0 0 minus 1. This all get 0, this all get 0. Okay, so this all get 0. Here this will be 1 0 0 0 0 0 minus 1. Okay, this all get 0, this whole get 0, this whole get 0. Here again 1 0 0 0 1 0 0 0 minus 1. So if you add all that, then this will be how much characters? You will have to add all this. Then characters of sigma yz will be say 2 2 4 2 6 minus 1 minus 2 minus 3. This is going to be the values 2 3 4 5 6 minus 1 minus 2 minus 3. So 6 minus 3. Okay, this is going to get value 3. This is 2 minus 1 1. This is 2 minus 1 1. This is 2 minus 1 1. Here 1, here 1, here 1. So total equal to 3. Okay, so if you summation of C to B, then one is E, C2Y, sigma YZ, and sigma XY. So you get that reducible representations 3n coordinate systems. What is the value for E? How much we get? For E we get 9. Okay, this is for E we get 9. So for E we get 9. And for C2Y, how much we get? For C2Y you get minus 1. I will write minus 1. And for sigma YZ, how much we get? Sigma YZ we get 1. So we will write 1. And sigma XY, how much we get? Sigma XY we get 3. So this is the reducible representations on the basis of 3n systems. So everywhere if you do like this, for ammonia, if you search for ammonia, this is how many atoms? N equal to 3 4. So 3n equal to 3 into 4, that is 12 coordinate systems. So everywhere if you do the same things, then it will take lot of times. So for that we use the shortcut. We will not use this formula for all the times. Okay, so we will not use this formula. This is just for understanding. So we will use only the shortcuts. How to do the shortcuts? Shortcut, let's say that, let's say C to B, that is E, C2Y, sigma XY, or sigma YZ and sigma XY. What we will do? We will draw the structure of water molecules. Okay, here first we do that number of unshifted atoms. This means number of unshifted atoms. Number of unshifted atoms. That is, we can say that Na. Okay, so number of unshifted atoms. If you apply that E, so number of unshifted atoms, if you apply this, nobody will change, so this will become 3. And if I apply C2Y, then I'm applying C2Y this directions, because this is my X, this is my Y, this is my Z. C2Y if I apply, then this is H1, this is H2, this will get replaced this one. So which number of unshifted atoms, so this is getting shifted, they getting changed, so which is not changing, oxygen is not changing, so how many number of atoms which is not changing, that is 1. Okay, similarly if I apply sigma yz, then this I have to apply these directions, so which are not changing. So after that what will happen, this here H2, here H1, so how many not changing, only 1, that is oxygen. Okay, now if we apply for sigma xy, then this is nobody is getting changed, but this is just going to the back. So we ask that number of unshifted, so 3 are not shifting. Okay, so this will become 3, because 3 are not shifted, so this I ask the number of unshifted atoms. If after applying this symmetry operations, so if I apply this asymmetry operations, nothing getting interchanged, this is just get the back sides. Okay, if I apply sigma xy, so nobody is changing, so this is 3. Okay, after that what we will do, after that we apply that reducible representations for XYZ basis. So XYZ basis, what is that? For E, that is 3, for C2Y, that is 1, for sigma YZ, that is 1, this is also for 1. For XYZ basis, we have already discussed that. There is there. Yes, that is 3, this is -1, this is 1, this is 1 on XYZ basis. Okay, so this we already should remember. This one is very easy to remember also. C2y -1, this is always 1, this is always, this is E always 3. Okay, that we will put here now. This is -1, C2y is -1, and this is 1, this is 1. Reducible representations on XYZ basis. After that, what we will do for reducible representations 3n systems, what you do, just multiply with this. So this will become 9, and this will become -1, this will become 1, this will become 3. So this is the products. Okay, we have not to do that type of the log methods. We will simply do the number of unshifted atoms. After that we multiplied with XYZ basis, because this is easy to calculate, because this is simply that characters of E, that is 3 characters of C2y is -1, character of sigma is always 1, so multiply with that, we will get the reducible representation in 3n coordinate systems. The same things is 9 -1 1 3, 9 -1 1 3. Okay, so similarly for, if we say that NH3, so this will look like this. So here the total atoms are 4, so 4 into 3 equal, this is 12 coordinate systems. So if you do the long method, it is very tough. So what you do, we will apply this shortcut terms. So the point group for NH3 is C3b. So what are the symmetry elements? C3b, that is E plus C3 plus 3 sigma b. Okay, so now we will do that operations here. See E, if you apply that number of unshifted atoms. So for E, no atoms will be shifted. So how many atoms are there? 1, 2, 3, 4. So 4 I will write. And C3. If I apply C3, then C3 will come. How will come the C3? This is the nitrogen atoms. Yes, this is the nitrogen atoms, and C3 will come passing through this and coming to this direction. After that, this 3 will rotate. So number of unshifted is only 1. Okay, and sigma B if I apply, then this sigma B will that will cutting that hydrogens and nitrogens. So 2 will not shifted, 2 will get changed. So 2 will not shift. Now we will do that XYZ basis. Reducible representation of XYZ basis. What are that? E is always 3 and C3 is that is 0. We know that characters of C3 is 0, and this is sigma is always 1. So that is the reducible representations in 3n coordinate system will be, this is multiplied, this is going to be 12, this is going to be 0, this is going to be 2. This is the for 3n coordinate systems. Likewise, any molecules will there, first write that point group, after write that symmetry elements, and draw that, find the number of unshifted atoms by applying that symmetry operations, and after that characters we do that. Characters we know that how to calculate, we have discussed in previous class. After that multiply it, then we will get reducible representation in 3n coordinate systems. Okay, so now the last basis on which we derive that reducible representations, that is on the basis of bond vectors. So in these things, one things we have noted that here unshifted are bonds. So unshifted atoms you are saying here, unshifted are bonds but not atoms. Okay, and another things that here that characters of X, Y, Z axis, this basis what you are doing, basis are always taken as one only. Okay, so that things you have to remember. So let we take the example, then we will understand. Let's say I will take first for water molecules, water. Okay, the point group is C2B, that is E plus C2Y plus CYZ plus sigma XY. So number of unshifted bonds. Okay, so if I apply CE, then which the number of unshifted bonds are, so bonds here, this is the bonds, this is the atoms. So number of unshifted bonds, E will nobody will nothing will shift, so number of unshifted bonds are 2 bonds are there, so this will be 2. And if I apply for C2Y, on that case this and this get interchanged. So if this is get interchanged, then no bond is left, all the bonds are changes, so unshifted bonds will be 0. And similarly for if CYZ, if I apply, then I have to apply by this, so then this and this get reflected, means all the bonds are changes, so this is also 0. And if I apply that sigma XY, that is cutting through all the bonds, then the 2 bonds are not changes, so same, on that case this will be G2. Okay, now that reducible representations X, Y, Z axis, on that basis we have to take all as 1, so you have to take 1, 1, 1, 1. then we have to multiply it. That is reducible representations or bond vectors. That is multiplied. We have to multiply. This is become 2, this is become 0, 0, this is become 2. So this is the answer. Similarly, if you take any ammonia, let's say this is C3b, this is E plus this is C3 plus 3 sigma b. The number of unshifted bonds are, what things are there? So E, if we apply, how many bonds are there? 1, 2, 3. So 3 will not change. And C3 if we apply, then all will change, so 0. And if we apply that sigma, then that is sigma will apply. Let's say this is the atoms. Then if I apply that sigma, then that will cutting one this hydrogen and nitrogen. So one bond will not change. So this is 1. Yes. So now reducible representations on x, y, z basis all will taken as 1. So 1, 1, 1. If we multiplied it, then that is reducible representations by bond vectors. That is become 3, 0, 1. Okay. So today up to this, we'll discuss more in next class. Thank you.